Hello, everyone. Welcome to the workshop series on Introduction to Deep Learning. I am assuming people online can hear me. Can you hear me? Okay, I should be loud. Um, so, yes, okay. You know what? I'll come sit there. That way you can also. Give me a second. Okay. So, in this workshop series, we are going to go through the basics of deep learning. And more importantly, we're going to try to make it as hands-on as possible so that even by the end of today, you will have tools to start using deep learning or even generative AI in any of your projects, or at least you'll know something about it. So this happens every Thursday this semester at 3 p.m. at the Weaver Science and Engineering Library. And if you're on the Zoom link, you already know where you are, where to come back here. So before we start, I wanted you to introduce you to Hugging Face, which is not just the emoji. I wanted you to go open a tab in Google and go to huggingface.co or just Google Hugging Face. And if you don't have an account, can you sign up for it? It's free. So clearly, unless you are rich enough that you want to pay for it. But please sign up for it, and we are going to need it in another 30 minutes. Okay, so let's start. So I wanted to start with this question. It's a trivia question, and the question is, identify this famous person taking selfie with his friends. Does anybody have an answer, online or in person? I am not monitoring the chat. Okay. I think
Abe Lincoln or something.
Okay, so somebody here in person says this is Abe Lincoln, and he's right. So this is Abraham Lincoln taking selfie with his friends. So clearly there was no selfie at that time, but right now we have a picture in which Abraham Lincoln is taking a selfie. And this is the next trivia question in that case. Identify these famous people. Something on the chat. Type out your answers, say them out loud in the chat. Oh, okay. All right, I'll give it a couple of seconds for people online. 3, 2, 1. And people in person also don't have an answer. Do you have an answer?
I feel like it's a trick question that it's just like AI generated.
Yeah, so the answer here was it is a trick question and this is all AI generated. And you're right, these are all AI generated people. These are not real people. So this is essentially what the power of generative AI right now is. Welcome to the world of machine learning. If you were here in the previous talk an hour ago, which started an hour ago, machine learning is the big umbrella under which part of which is deep learning right now. At the end of the day, we are trying to teach machines to behave like humans. So welcome to the world of deep learning. The first question I have for you, or at this point, the third question is, what do you think is intelligence? People online can unmute. I cannot keep an eye on the chat at the same time. Feel free to answer. What do you think is intelligence? Do you have an answer?
I would say something to do with like adapting and perceiving, predicting.
Okay, for the people online, we have an answer here in person, which says intelligence is basically something to do with adapting, learning. Is that what you said? Perceiving and predicting. So are humans intelligent?
Yeah.
Sure. Okay. By that definition, humans are intelligent. Is ChatGPT intelligent?
I guess not in a classical sense.
Okay, so you're saying not in a classical sense, but what is the non-classical way? Why do you think it's, even if it's a little bit intelligent?
Uh, maybe it's not intelligent because isn't it pretty much just regurgitating answers?
Yeah, so the answer here was just, I'll just repeat the answer here in person, which is, isn't ChatGPT just regurgitating answer and it's not really intelligent? And that is right. ChatGPT is a very big memorization mechanism. It has seen insane amount of data, almost every data point on the internet. And most likely the question you're asking, it has already seen the answer to it, and it's most likely showing the same answer to everybody who is asking the same questions. So in that case, what is deep learning? So why are we in this class, right? So if that is yet another tool, the answer is yes, it is. At the end of the day, it is doing that, which is it has seen all these text that exists on the internet, but there is still an intelligent process when it comes to picking the right answer and trying to tell you, it could have answered any of the 1 trillion sentences it had seen. So how does it get to the point of picking the right answer? These days, 95% of the answers the GPT says is right. So what is that process? So that process of interacting with the question, understanding the question and retrieving it, that is so far slightly what we call intelligence. So in this course, that's what you will be learning, how that works and how you can actually try doing it yourself. You can create, in fact, in one of the next classes, we will create our own chatbot for free. We don't have to pay for ChatGPT. So that is also part of the hands-on we have part of this course. So I guess you guys are familiar with all these models, which you'd have heard of ChatGPT, if nothing else. And the other models are called, from Meta, there is Llama, there is Google's Bard, Lambda, Palm. All these belong to a group or name called large language models. So what is a large language model? Does anybody have an answer? What in your mind is a large language model? There is no wrong answer, okay? Just say whatever you want because we will get to it anyway. So whatever you think is a large language model.
I think it's like some contextual model that's able to look at words and put context based on sentences.
Okay, so the answer here in person is, it's a contextual model which given a word can put context around it, or vice versa, I'm assuming. Right? Because if you're given a context, the question you're asking is in a way context. It's almost like saying, we live on Earth, where does the sun rise on Earth? So essentially, when you're asking where does the sun rise on Earth, we are kind of adding that inherent context to it, which is we live on Earth. I think we do. Last time I checked, we were. But the answer there is a large language model is something which understands human natural language. So if you think about it, our species have been speaking this language for a lot of years. But take a step back and think about it. What is language? We kind of take it for granted. When a kid is born, it slowly finds words and sentences and meanings, and it starts slowly building up. But we are exactly at the time when we are trying to create our own little kids made of metal, which is ChatGPT. And we reached a stage of, how do you explain natural language to a kid? A human kid is adaptable, so let's assume there's a brain given to you in the form of ChatGPT, which in fact uses something known as neural networks, which is exactly a copy of human brains, and we will get to that in a second. And the question then is, if you're given a huge collection of neurons, just like in a brain, how do you explain what a language is to that metal box? At the end of the day, it's just a metal box. Human brain is also, at the end of the day, a connection of sensors. So how do you explain that? So that is actually what we call the field of natural language processing. And the latest invention from the field of natural language processing is a large language model. But this is, you probably haven't heard of this in the last, you probably have heard of large language models in the last year or two, but this has existed, the whole research has existed for at least half a century already. It just happens to be, we all happen to be at the right time and place in the world that this great invention became easily accessible to the public, but the research has always been there. So then the question is, how do they do it? How do these models do the supposed great things that it is doing? Because if you remember the very first picture of Abraham Lincoln with Abraham Lincoln and his friends taking selfie, at the end of the day, it is a language model which is sitting underneath it. And if what happens is you can go to the command prompt of one of these models, I'm going to show you soon, and you can type a command like, show me a picture of Abraham Lincoln taking selfie with his friends. So the core of the work is at this point done by the language. And in fact, at the language level, the machine understands the meaning of give me a picture of Abraham Lincoln with his friends. So it understands who Abraham Lincoln is and is capable of producing something, let's call it a blurb, and it's capable of producing a blurb using which that picture you saw was generated. So the answer is, simply put, these machines work by understanding human language. And it is not a simple task. Human language, as you know, humans have so many different languages in itself, but I'm not even talking about the different kind of languages in the world. I'm talking about this idea of how does an idea in your head translate into another person's head. Even take this example, I am talking to you. I have an idea in my head about what I'm going to speak, and then I speak it in whatever language I choose. And if the person who is listening understands that language, he then forms an idea or a mental model in his head. So that is the fundamental research that is underlying all this, and which, if you think about it, is very tricky, right? That is the only way we can transfer ideas from one head to the other. And now we are trying to do that in a metal world. So this is the website I was telling you about. If you go to midjourney.com, you can ask it questions like, can you give me a selfie with Abraham Lincoln? Or you can think of anything you want and it'll give you a picture. Very, very artistic it is. In fact, there is not just one, there's a ton of these kind of image creators right now. It's called DALL-E, Picasa AI, Artbreeder, DaVinci, etc. And on the text side, as you know, there is GPT, and there are a lot of these, you can just Google the large language models like GPT. But yeah, right now GPT is the very most powerful, and which is why that is paid, or after a point of time, you cannot use it for your own work unless you are a millionaire or a billionaire. So which is why we are having this course in the first place, to introduce you to the other equally good models, which you get for free and which you can start playing at home with. You don't need to have the resources that GPT provides. Like, you don't even need a high performance machine, because we in this course will be learning how to access high performance machines for free. So these are some of the other pictures that was generated by the same Midjourney bot. Everybody taking a selfie with their friends. This is presidents of countries playing the Indian festival of Holi, the color festival. It's okay. Elon Musk is also a president of his own country, his own ego, United States of ego. But you have Putin, you have Kim Jong-un. I'm pretty sure none of them ever visited India or played Holi. So to understand how this works, you need to kind of understand how the history of human species works. Human species was. So humanity originated around 170,000 years ago in Africa. And since then, we started moving out. And at some point in the history, we suddenly became intelligent. And my definition of intelligence is, at some point, at one single point in time, we became good enough, intelligent enough to speak a language. Sure, you can have other layers of it. Like you said initially, perception can be another layer, but the whole idea of intelligence is there was a medium by which the ideas in one person's head was translated to ideas in other person's head without, let's say, sign language or writings on the floor. There was a free flow of information. And it is widely accepted right now that there was like a one catastrophic, or in this case, a good event that happened 100,000 years ago, during which we suddenly started saying full-fledged languages and sentences in whatever language was existing at that time. And in fact, it's called Adamic language. In research, Adamic language is a term used for that one single language all humans were speaking just after we were a monkey man trying to say garrulous sound. So what happened to humans 100,000 years ago? So like I said, there are two major theories, actually. One is the continuity theory and another one is a discontinuity theory. The continuity theory says around 100,000 years ago, we just evolved across years to have the ability to transfer the ideas in one person's head through words and a language into another person's head. But the second school of thought is what I mentioned, which is known as discontinuity, which also big people like Noam Chomsky have subscribed to. And they say there was some kind of a divine intervention, whatever you want to call divine. Let's call it some kind of a event that happened and humans suddenly became intelligent. We don't know the answer for sure. Most of the research in linguistics and natural language processing kind of believe the second one, which is there was one single event that made us intelligent or able to speak language. But more importantly, we are thinking about that at this time because we are now at another situation like that. We are playing God. We are telling a machine, and the machine is understanding the idea in our head. We are expressing it in natural language. In fact, this point was predicted a long time ago, and this is known as a point of singularity, where human intelligence is going to combine very close to machine intelligence, and we start creating transhumans, cyborg, or whatever you want to call it. This was predicted a long time ago that we are going towards it. So essentially, whatever happened to humans here around 100,000 years ago in this place here is exactly repeating now. We are creating little humans known as ChatGPT, and almost as you are aware, we all are transhumans because we have a thing called cell phone in our pocket. Turn it off for 24 hours, you realize you are dead. You're as good as dead. So we are in a part very dependent on these machines, and these machines and their intellectual powers have come up pretty far. So the question is, how did this happen, right? How were we able to tell the machines what humans speak and make it understand the language? So the field is known as natural language processing. And simply put, that is the idea. If I give you 1 trillion neurons, either in a metal or in a biological form, how do you explain what language is to it? And that we were able to achieve in the last decade, and that's what we call deep learning. And the word deep in deep learning means it's a deep network. So earlier, it was very shallow networks where we had 2 or 3 neurons, which is like 20 years ago. But then in the last 10 years, the hardware became so easily accessible and more powerful that we were able to have trillions or even trillions, whatever is bigger than a trillion, of neurons inside what we call a GPU now. And the networks became so deep. And believe it or not, the truth is we don't know how these machines are doing it. Let me put it this way. We as humans, we kind of understand how we translate the natural language and give it to the neurons as signals, but how it is retrieving it is still a mystery, and we will learn about that in this class. So let's start and find out, how does deep learning work? as I said, deep learning works on things called neural networks, which essentially are technically artificial neural networks because the original neural network is in the human brain. Because your brain is the neural network, the deep learning machine, and we were just trying to replicate it. In fact, the first neural network was invented in the 1960s, at least on theory paper. And in a way, the computer we have right now is a way of neural networks where we have transistors, which understands only 0 and 1, but it's like a vague approximation of neural networks. Right now, the neural networks, the term is used for a collection of neurons, software neurons purely, which are so deep that they can come out with emerging technologies and ideas. And we'll see how it is doing it, at least to some extent. And then you'll realize, oh, we don't know how it is actually answering the question, because it's just like asking your brain, do you exactly know how your brain is going in and answering? We don't really know that. But let's see piece by piece how these machines do it. Okay, another trivia question. Where do you see this sign almost on a daily basis? Car. And what does that do in a car? It's just there. Okay. So this is basically a cruise control in cars. And usually this is how cruise controls are, the symbol for cruise control. And in fact, the neural network or deep learning is as simple as a cruise control. So how does a cruise control work? So it's a constant feedback mechanism between expected speed and current speed, right? So let's say you're going at 40 miles per hour, or in this case, you are going at 42 kilometers per hour, miles per hour. And then you tell the machine, I want you to cruise at 41. So what happens at that point is your current speed is 42 and the expected speed is 41. And then the machine the first thing is it has a forward pass where it sends that knowledge of, oh, I am currently at 41 and I'm currently at 42. And then what happens is there's a feedback loop, which is a signal coming back to your accelerator or a brake at that point saying, can you slow down because the expected speed is 41. So as you can imagine, there's a feed forward and a back propagation kind of network. And that is exactly how neural network is working. It's a constant feedback mechanism between expected value and the current value. So all these neurons, all we do is pass information through it front, back, a million times. And surprisingly, it learns something from that process. So this is how, if you open up a deep neural network, this will be one of the fundamental things. Or rather, this was how a neural network looked originally when it was created 50 years ago. So the idea was we have an input layer. So each of these layers are neurons, just like your human neurons. If you remember your picture of neuron from your high school biology classes, it is essentially doing one simple thing, which is take inputs from a lot of neurons, do some calculation, send the outputs to the other neurons. That's what every single neuron or nerve cell is doing inside your head. But humans took it to the next level and completely recreated this one after the other, layers and layers of dense neurons. As an input, we start by giving it, let's say we give it a picture of cat, and then we ask the neuron, initially we ask the neuron, hey, what do you think this is a picture of? So neurons, just randomly, initially it's completely random, just sends out these signals from one neural network to another, one layer to another. They're called hidden layers. Hidden only because the first layer is the input we as humans can get access to. Everything beyond that is hidden from the human view, so it's just called hidden layers, nothing fancy there. But what happens is the very first time, it just sends out these signals across all these neurons, and neural networks, and it comes out with the answer, hey, I think it's a dog. But then we as humans tell the machine, no, 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 it's a picture of a cat. So then it calculates a difference between the pixels of cat versus pixels of dog, what it predicted to be pixels of dog. Something, basically, whatever you want to call the difference, what is the difference between a dog and a cat? Let's say the difference is that cats have long whiskers and the dogs don't. So you can think of it that in this way, that the difference of an idea is now back propagated all the way through all these neural network layers. And what happens in that process is each of these neurons looks at the difference and starts thinking, oh, so I thought it was a dog, but it was actually a cat. And here's the difference. Here's what I was missing. So each of these neurons learns something in this process and adjusts the weight of its output. So now it starts realizing, oh, I had earlier sent equal signal out of me to each of my outputs, but that gave me a wrong answer. This time I'm going to try sending more of my signal to the first output and let's see what happens, right? So that's all it's doing. And then this keeps happening then it goes back and it tries predicting again. Its second time it says, yeah, I think it's a dog. And then the humans again say, no, it's a cat. You are making some progress, but it's still a cat. So in a sense, the neural network plays with this architecture feed forward and backward for trillions of times at this point. Finally, until it gets all the neurons to arrive at the weights it wants to assign to each of its output. And finally, they get the right answer. So this process keeps happening until it starts predicting that the picture we gave it was that of a cat. That is essentially neural networks in 2 minutes. So the only difference what humans did in the last 1 or 2 years is we took the entire internet, packed it up nicely, and gave it to the input layer. And ta-da, that's called a large language model. So essentially, large language models are nothing but the reflection of the internet passed through a huge network of neurons. If you did not have internet, it was not large, it could have been a deep layer, but it still could have been used only for small tasks like, what is this picture? Is it a cat? Is it a dog? Now, there are 2 phases of the machine learning process, which you should be familiar with. The first phase is called training, and that's what we saw earlier here when we give it a picture of a cat and tell it that it is a picture of cat and not what it predicted, find the difference and do a back propagation. That process is called training. And this happens for, like I said, for millions and billions of cycles. The second part is what we call prediction, which is we give it an entirely new picture, not a cat, not a dog, but something the machine has not seen before. Say, for example, we give it the picture of a parrot, and we never trained the machine on what a parrot is. The machine still answers correctly. That exactly is deep learning, that the ability to answer about things it has not seen before. If it was simply teaching it what a cat is, we could say, here are the pixels and here are the red, green, blue values. Anytime this red, green, blue value occurs, it's a cat. But it's not as simple as that. So humans tried so many ways of telling that to machines. In the last 2 or 3 decades, that's exactly what humans said. Okay, hey, maybe try sum of all red, green, blue values. Maybe try average of red, green, blue values. After around 20, 30 years of trying that, we just gave up and we just said, no, here's a picture. All we are going to do is increase the size of the neuron layer. We don't know what it is learning. We don't know what the machine's definition of cat is. But surprisingly, by the process of giving it the picture of cat and telling it this is a cat, and doing that for tons and tons of data points, let's say we had pictures of all animals and birds except parrot. By doing this feed forward and backward, it has learned something at an abstract level, which then it uses on the picture of parrot to tell you it's a parrot. If you ask me, that's a little bit of voodoo and magic at this point, but the truth is, we don't know how the machine is doing it. It's projecting all this knowledge to a plane which humans cannot imagine or visualize, and is able to find the answer or very subtle patterns, common patterns between cats and dogs, or why is a cat different than a dog in terms of pixels. Pixels is a human interpretation. So it's essentially pushing it all onto a higher dimension and finding the nice little patterns inside it. That's all large language models do. It's essentially discovering hidden patterns in data. And the word hidden is used here because it's hidden to humankind. Or at least if I give you a picture of cat and picture of dog, you cannot completely explain the differences between cat and dog just from the picture alone. You can probably use a lot of texts saying, hey, a cat has whiskers, dogs don't have, cats meow, dogs don't. But imagine the machine being able to do that just from pictures. So that is essentially what is deep learning. It's discovering hidden patterns in the data. So it is able to see the hidden patterns, and we don't know what it's doing, but it's seemingly telling you right answers for the questions you ask. So it is, which is why exactly we have GPT, and people are kind of in a surprised of kind of a feeling right now, wow, this machine is finding patterns which we did not realize existed. So that is how we have generative AI models. So earlier when I was saying, asking the machine the question of, hey, so what is this picture of? And it tells me parrot. That was not generative. Generative is nothing but we just turned it around and said, okay, now I want you to produce new things. If I give you the text word of parrot, I want you to draw a parrot from whatever ideas from the plane that you have found the patterns in. So there is this one fundamental thing that every neural network model has. It's called transformers, or BERT. And it's got nothing to do with the Transformers, the movie, but they happen to name it it was transformational, and that's why it's called Transformers. And in this course, we will learn about this guy, the transformers, fundamentally, so that you can build your own large language models. So again, why should you care? Or why should we as humans care? Like I said, object detection, classification, and all these kind of nice tasks, which was tough to explain to a machine at that time, is now being easily done by these machines. As you know, like not just in the text field, right now we have so many visual friendly AI tools which can do all this for you. So we also have text-based tasks, like I mentioned earlier, with ChatGPT, of course, you're familiar with. If you ask it to give the sentiment of a sentence, and it gives it perfectly, it'll tell you if I tell ChatGPT, my experience so far has been fantastic, you tell me what the sentiment is. It'll exactly reply, yes, that sentence has a positive sentiment. Imagine, how would you explain what a positive sentiment is to a machine who has never seen anything before? It's easy for you to explain that to another human because the human understands what positive means. That is one of the tasks which machines are being used right now. There are a lot of these tasks like text classification, machine translation, which is, given sentence in one language, automatically create it into another language. And more importantly, it's useful in real life because right now we have large language models in healthcare, which are being used for things like understanding medical transcription or doctor notes, not just because doctors' handwritings are bad, but more because doctors write in plain text, which then needs to be converted into electronic health records so that the next doctor can easily understand it without having to read paragraphs and paragraphs of what the previous doctor has written. If you think about it, it's a very challenging task. So great, but why am I teaching you all this theory if you cannot do anything hands-on with it, right? The question is, how accessible are these AI models? The answer is it's right on your fingertips, and which is why I was telling you get an account on Hugging Face, because that is what we are going to do now for the rest of our class. So I want you to go open your laptop, go to the browser and type this out, which is github.com/UA-data lab. If you are already in the previous class, you might be there. I want you to go find the repositories we have and go to DL workshops, lecture 1, intro to Hugging Face. And this is the Jupyter notebook, which we will be using. Don't worry about all those terms, Jupyter. It's just a text editor, if you want to call it, which runs Python code. But more importantly, click on this link here, open in Colab, and it should open you something known as colab.research.google. So essentially what this is, it is a page where you can type the instructions in Python, and instead of running it on your computer, it will start running it on your machine. Sorry, instead of running it on your laptop, it runs it on the cloud and gives you the answers to it. Enough speech, let's start creating ourselves one. So let's try, let's see, file, new notebook. And let's see, I'm gonna bring this outside so that we can switch between this and that. Okay, so here you can see, if you click on the arrow next to the connect, you can see you can change the runtime type, and you have access to huge machines like T4 GPU, a TPU, which is a tensor processing unit, and a lot of these nice things you can access for free. Anything bigger than this, like A100 is a very premium GPU which exists in the world. For that, you have to purchase additional compute units, but that is for today. In the next few lectures, we will even show you an inbuilt way we have at University of Arizona, where we can run a lot of our calculations on heavyweight machines. So let me see, in this case, I'll pick T4 GPU. And it doesn't matter for this code which we are using, doesn't matter if you're running it on GPU or CPU. GPU is preferred. So we start with this, pip install transformers, and I want you guys to type this out with me. And what this does is, if you're not familiar with what pip is, in Python, pip is like a repository. You can pull down a lot of these models, which is already shared there inside pip. So type pip install transformers and press the play button. If you are following me, it's going to take a couple of seconds, if not an entire minute to install. I'm going to go get some water. It installed for me, so I'm assuming it installed for you also. Go back to the model we had earlier, the page we opened. The second one is says from transformers import pipeline. So I'm going to type that. If you press this, okay, we can start a new code block. We say from transformers import pipeline. So why did I talk about Hugging Face earlier, right? Hugging Face is another repository where you can find where people have stored all these open source models. So like I said, Transformers came out in 2017, and everything we see today is based out of Transformers. And when we did pip install transformers, this is essentially what we are doing. We are downloading a state-of-the-art machine learning model, and which is of course used for all these things like natural language processing, computer vision, which is everything visual, like a pictures and the selfies, pictures and classification. Selfies or creating new selfies is the generative part, which we will also get into in a bit. There's audio multimodal facets to it, which all will eventually touch upon. So if you go back to the same page, the next line is, oh, I wanted to show you pipeline. So that's how I ended up here. Hugging Face pipeline. So what these guys have done is they have created a nice way of adding things one after the other. They have created a pipeline for you. So a lot of things at this point is hidden from you, but that's okay. We are going to get into the details in the next few classes. But pipeline essentially has things like text classification. For example, if you give it the sentence, "This restaurant is awesome," it'll give you the positive label. So let's try that. So classifier, pipeline, sentiment analysis. Let's go back to where I was starting, right? So it says classifier equals pipeline sentiment analysis. Analysis. So like I said, this is already standard terms which Hugging Face has put a wrapper and abstracted out for you. So let's try running just this alone, just to make sure there is no spelling mistakes or typos. Okay, so it tells me no model was supplied and defaulted to Distilbert. So essentially what it is telling you is there are so many models that Hugging Face has, which you can learn, which you can use. Let's say huggingface.co/models. And in fact, one of the models right now is GPT. You can directly use a GPT from there, GPT-2 at least. Then we have Llama, which is also accessible there. Let's see, Mistral. Mistral has a lot of these models. So these are all right now the best models in the world. So you can see it's updated December 15th, less than a month ago. So a lot of these big models, you can use anything you want in here, and we'll show you how to do that. So, but more importantly, we already have a pipeline which can do the sentiment analysis for you. So next thing, all you have to do is type a sentence for the classifier. It's an object that is created, and you're asking the object, give me the sentiment of, I love, I don't know, deep learning, right? I'm gonna run this again. Yep, it says the label positive. The score is 9.9983. So basically what it's saying is, I think the sentiment of this sentence is positive, and I'm 99.98% confident that in my answer. So let's try, I hate deep learning. I am actually going to take this out into a new code block so that we don't keep creating a new object every time. So when I say I hate deep learning, it basically says the sentiment is negative. Let's see what happens if I say something like a neutral hedging phrase. I am okay with deep learning. It says it's positive. I don't completely hate, but I'm just messing with this. You can play this at home. Yep, it still says it's positive. You see where I'm going with that, right? So the same thing. Now that if you go to the pipeline page I had shown you earlier, you can actually find a lot of these tasks which you can do, like text classification, and you can pick which model you want, right? So like I said, if you want to probably use some GPT, you can paste that here. So let's go back into our page, which we are creating. I'm going to call it this way: pipe equals pipeline of model. Or in this case, we are just passing model as a parameter. Let's see if the syntax will work. Probably going to backfire. because I haven't tested it. Maybe not. So this is, and so anything you has the word BERT in it is basically a wrapper on top of transformers. Okay, let's see if that's gonna work. Apparently this one is better. See, the default model was bad and this guy is slowly getting it to the neutral. So that's the brilliance of better models. So let's see, we can go Hugging Face and any other latest models will give a better answer. Mistral, if you don't know, is one of the better models. I don't know if this is going to be as simple as that or they need something else in the constructor, but let's find out. Yep, not going to be easy. It probably needs a bunch of other stuff, but you see where I'm going with that, right? So you can go and figure this out and play with it and just do this on your own. But more importantly, I wanted to introduce you to the text generation part. This is the fundamental of generative AI, as you know, is essentially which you know as ChatGPT. So same thing from transformers import pipeline, but this time we are going to say classifier equals pipeline of text dash generation. Let's see what that happens. No model was supplied. It defaulted to GPT-2. That's nice. So if it sees text generation, looks like it by default picks GPT. And let's say Arizona is known for blank. Okay, it does something. Arizona is known for ickiness. All right, so this is where we go into the shady world of hallucinations and GPT. So it says Arizona it's literally copying it from somewhere, right? It has seen this sentence before and it's saying Arizona is known for ickiness, but even those without a lot of experience in the sport. All right, that's when we press it again and it gives a different answer. Arizona is known for a lot of things, even if it isn't the sort of thing you're used to from Seattle. I suppose I get the urge to call Seattle a little out of place for our school sports. So again, these things are literally telling you what it has seen before, sentence it has seen before, for Arizona is known for. Now they even have, let's call it question answering. So there's question answering. You could probably just call it model. Classifier was we are only classifying the very first thing. Right now, we are just creating a type of model which is trained for question answering. And we are asking this has a particular syntax. The way we want to ask it is, this will be our model. And where do I work? So here, for example, we are on Earth. Where does the sun rise? That's my question, right? Okay, it says the answer is Earth. You can ignore everything else. It's just giving you the start and end tokens and the scores or percentage of it. So the context is essentially we are telling the machine like a primer that we are on Saturn. Where does the sun rise? Yeah, it's not smart. We are on Saturn and sunrise on Saturn. Okay, if we are on the moon, where does the sun rise? Yeah, it's a stupid model. So it has memorized some stuff, but that's probably because it's GPT or whatever the model we are using in the background is. It's default Distelbert. That's like a 5-year-old model. So on and so forth. If you click on this page, you can see examples of everything, including summarization, generation, text generation, question answering. Or if you're done with this, you can just go look for pipeline and pipelines here, and it will give you a long list of things you can do. You can even do automatic speech recognition. These are text classifications. And basically my goal here is to teach you how to fish. And this is how I'm teaching you how to fish. This is the fundamental thing you need to know if you are learning anything in deep learning, or if you want to use one of the state-of-the-art models. If you have time, I would suggest go look into LangChain. And this is the next level after Hugging Face, where you can directly, it's more abstracted and more easy to use. But I would rather teach you the Hugging Face first, because that is essentially what LangChain, it's chaining a bunch of things like Hugging Face. Also, another thing I would like you to do by the next class is download Llama. And Llama is Meta from Facebook. It's the open source model. Just click on download the model. It'll probably ask you all these details, request access. Everybody gets an access, especially if you use a university ID. And then there's one more thing on Hugging Face. We will use Llama. And I think there, if you go to these two pages, Llama, get access in the Facebook page and get access on Hugging Face. I think if you go to this page for the first time, it will ask you for, please sign up for this or something like that. Yeah, okay. So these are a few things I want you to do next time, which is download Llama and give access for Llama on Hugging Face. So then we will go back and play around with all these things. In fact, create our own chatbot. And once you're familiar with it, creating a chatbot is very easy. It's you just put a wrapper of chat on it. So we will see that in the next class. I am going to stop here and ask if you have any questions. Anybody online or anybody in person? There's a question on the chat. Thank you so much for the introduction. Okay, thank you. You're welcome. Do you have a question anywhere? Anyone else?
I was just gonna ask if you can do if there's a pip install command for the Llama.
Yeah, no. So we'll get
Yeah.
to that in the class together. I
Okay.
just want you to download the model. Once you do this, you'll have it.
Okay, so
It'll give
get
you access to a link, basically. Get an access, otherwise you cannot download it directly.
Okay, that's kind of what I figured.
Yeah. Now, if you are feeling adventurous enough, you can go to UA Data Lab and go through our DL workshops. And I think chatbot over LLM, it's on lecture 5. So we have a chatbot, fully functioning chatbot there. And we have the code for it. And one thing, if you're new to computer science, one thing I will suggest is do not copy paste code. That way you're not learning anything. Do what I did, look at the code, understand it, and try typing it out yourself, because otherwise you're not going to learn anything. You're not going to remember anything. You don't get that human connection, well, machine connection to it in this case. But yeah, we will be getting to the chatbot in the next few lectures. Any other questions, follow-up questions, contact us, UA Data Science Slack, or I am going to leave my email here. Ask the questions too. And we will be posting the slides. I think the slides are already up in the wiki page for if you go to the same repository and go to the wiki page, we should have all the slides also available, introduction to Hugging Face. And this is all I'm using exactly the same slides from last semester. So you can click on this and you can get to the slides. All right, any other questions, guys? People, girls, everybody. All right, thank you, everybody. Thank you. If you are attending 2 classes, thank you for doing 2 classes back to back. Hopefully you'll come back and would like to learn more hands-on with deep learning. Thank you, bye.
Thank you.